as ResNet 50, Inception ResNet V2, and Inception V3 for classification and comparison of new model with currently existing model to analyze the performance, to extend the model to detect fire in real-time surveillance video.
Okay. Now let's move on to implementation details. Transfer learning is the reuse of pre-trained model on our problem. To explain it in simple way, transfer learning focuses on storing knowledge gained while solving one problem and applying it to the different but related problem. For example, knowledge gained while learning to recognize cars could apply when training to recognize trucks as well. Those pre-trained deep learning models are used for feature extraction. This method is called representation learning. These are basically used for training the models. And supervised ML classification, that is machine learning classification algorithms like decision tree, naive Bayes, logistic regression, SVM, will be discussed in further slides. The methodology is called, as I told earlier, it's representation learning. And supervised ML classification algorithms are used for classifying the extracted features. And these are the models and algorithms we have used. That is deep learning models such as ResNet 50, as Digvijay already told. ResNet 50, Inception V3, Inception Net, ResNet V2, and classification algorithms like decision tree, naive Bayes, logistic regression, and SVM. Now, let us first look into ResNet 50 model. What is ResNet? A ResNet, that is residual neural network, is an ANN model. ResNet is basically used for image classification. And in ResNet 50 is a variant of ResNet model which has 48 convolution layers along with one max pool and one average pool layer. Now, what is max pooling and average pooling? Max pooling takes the maximum value within the convolution filter, and average pooling takes the average value of the filter. ResNet makes it possible to train up to hundreds or even thousands of layers and still achieve compelling performances. The performance of many computer vision applications other than image classification have been boosted, such as object detection, face detection, and even for handwriting detection also. And it is actually a feed-forward network. That is, as we can see, there is a jump or a skip in a flow diagram in the right side. Let us see what exactly that is. That skip or jump is called skip connection. What is actually the strength, which is actually the strength of ResNet. ResNet first introduced this concept. What's done here is the original input is also added to the output of a convolution block. But why? The reason is they mitigate vanishing gradient problem and also to flow information from earlier layers to the models to later layer. Even a single layer is sufficient to represent any function with ResNet 50. Now let's move on to the next slide. That is, ResNet 50 is predicting algorithm which we have used. This during feature extraction extract the feature as numbers, resulting in 2048 numbers representing a single image. That is, a single image is obtained as numbers which is of the size 2048. That is, total number is 2048 numbers. ResNet 50 also uses ReLU as activation function. ReLU, what is ReLU? ReLU stands for rectified linear unit. This function replaces all the negative values into 0 and retains the positive values, as you can see in the graph.
Coming about Inception V3. Inception V3 is a convolutional neural network that is 48 layers deep. You can load a pre-trained version of the network trained on more than 1 million images from ImageNet database. The pre-trained network can classify images into 1,000 object categories. Basically, there are two ways in Inception V3. One is naive inception model. It performs convolution on an input with 3 different sizes of filters, 1 cross 1, 3 cross 3, and 5 cross 5. Max pooling is also introduced here. The output are concatenated and sent to the next inception model. Here we use dimension reduction inception model. wherein it uses one cross one convolutions, as they are more cheaper than 5 cross 5, and there will be reduced input channels. The dimension reduction inception model performs multiple convolutions of 7 cross 7 dimension and max pooling technique on the given input data. The output of each module in an inception network will be summed up by global average pooling. The additional branches that you can see in this inception network are used when there is requirement of feature vectors that is used for some prediction.
Praज्वल?
Now coming to Inception ResNet V2. Inception ResNet V2 is a convolutional neural network that is trained on more than 1 million images from the ImageNet database. ImageNet means it contains more than 20,000 categories with typical categories such as balloon or strawberry, consisting of several hundred images. This function requires a deep learning toolbox model for an Inception ResNet V2 network support package. You can also classify new images using a Inception ResNet V2 network. The syntax is net is equal to Inception ResNet V2. This function requires the deep learning toolbox. Next.
Yeah, one second. Is it visible?
Yeah.
Hello.
Hello.
Continue.
Instead of having a single collection, we have a composition of average pooling by 1 then 5 cross 5 to a reduction A, then 10 cross 10 inception ResNet B and a reduction B, and again 5 cross 5 ResNet C, and average pooling will be done. In pooling technique, there will be both max pooling and average pooling, then dropout.
Now we'll go through the classification algorithms. Praज्वल? Is it visible?
Decision tree.
Yeah, it's visible.
A decision tree is a flow chart, like a structure, which each internal node represents a test on an attribute. A decision tree is a support tool which uses the tree-like models of decision and possible sequences like chance event outcome. A chance event node represented by a circle shows the probability of a certain result. Decision tree commonly used in operation research and
ಯಾರೋ ಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ ಪ್ರಜ್ವಲ್ ಏನೋ ಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಿರೋದು
and decision
Sir,
analysis,
ಹೌದು.
which
ಅದನ್ನ
helps to
ಓದ್ಕೊಂಡೋಗಕ್ಕೆ ನೀವು ಪ್ರೆಸೆಂಟೇಷನ್ ಅಂತ ಕರೆಯಂಗಿದ್ರೆ ಅಲ್ಲಿ ಎಲ್ಲಿ ಅದೇನೋ ಸರ್ಕಲ್ ಅಲ್ಲಿ ಏನೋ ಪ್ರಾಬಬಿಲಿಟೀಸ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಆ ಡಿಸಿಷನ್ ಟ್ರೀ ಅಲ್ಲಿ ಎಲ್ಲೂ ಸರ್ಕಲ್ ಕಾಣ್ತಾ ಇಲ್ಲ. ಸುಮ್ಮನೆ ಅಲ್ಲಿರೋ 3 ಲೈನ್ ಓದ್ಬಿಟ್ಟು ಮುಂದಿನ ಹಿಂದಿನ ಸ್ಲೈಡು ಅಷ್ಟೇ ಅದೇನೋ ಇನ್ಸೆಪ್ಷನ್ ಏನ್ ಅಂತ ಹೇಳ್ದ, ರಿಡಕ್ಷನ್ ಏನ್ ಅಂತ ಹೇಳ್ದ, ಅದು ಹೆಂಗಾಯ್ತು ಅಂತ ಏನು ಇಲ್ಲ. ಆ ಬ್ಲಾಕ್ ಡೈಮ್ ಓದ್ಕೊಂತೀವಲ್ಲ ಹಾಕ್ಬಿಡೋ 2 seconds ಬಿಟ್ಟು ಮೂವ್ ಆಫ್ ದಿ ಸ್ಲೈಡ್ಸ್ ನ ಪ್ರಜ್ವಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕಣ್ಣ. ಸುಮ್ಮನೆ ಓದಂಗಿದ್ರೆ ಬಿಡು ಪರವಾಗಿಲ್ಲ.
Sir, I'll explain diagram, sir. Example, consider if a person wants to go outlook. If it is sunny, he'll check if humidity is high or normal. If it is high, then he won't go. If it is normal, yes. And he'll check to rain. If it is tight, you'll check wind. If it is strong, then you won't go. If it is weak, then yes. If it is overcast, the result will be yes. Next.
Coming to naive-Bayes technique. Naive-Bayes is a classification technique based on Bayes theorem. This technique assumes that the presence of particular feature in a class is unrelated to the presence of any other feature. For example, if we take apple, the properties of apple are red, round, and about its size. All of these properties independently contribute to the probability that the fruit is apple. For example, by applying to the formula, if we find out the probability of red uh, apples which are red, we will take as those apples which are red. We will take the probability of those apples which are red, and the total number of red fruits in the overall fruits, and the probability of total number of apples in the overall fruit. So, the advantages of this naive Bayes is it is easy and fast to predict the class of given test data. It performs well in the case of categorical input variable. The drawback is the assumption of independent variables. We know that in real world there are no predictors which are independent. So the applications of this naive Bayes are real-time classification like we do in our project, multiple class predictions, text classification and spam filtering, and recommendation systems.
Okay. Um, our next classification algorithm is logistic regression. What is the main purpose of logistic regression, that is LR? It aims to measure the relationship between a categorical variable and one or more independent variables. Logistic regression is a kind of parametric classification model. That is, it classifies the different um, kinds based on the parameters of that material. For example, it classifies that whether if a plant belongs to a certain species or not. We not just fit a straight line in our data as we fit S-shaped curve, that is sigmoid curve. LR classification is actually dichotomous, that is, it is binary classification model. It divides into either category A or category B. In our case, whether it is fire or non-fire. So why LR? That is, what is the use of LR? That is logistic regression. They are easy to understand, interpretable, and also gives a pretty good results and easily implementable also. Yeah, SVM, support vector machine. SVM or support vector machine is a linear model for classification and regression problem. This algorithm creates a line or a hyperplane which separates a data into classes. Suppose we have to classify green circles from blue squares, which is shown in the figure. Um, we will have infinite lines to separate these two classes. What SVM does is finds the best line that separates the two categories. Now, in how SVM works, it first finds the closest point to the line. That these points are called support vectors. Compute a distance from support vectors and the line. This distance is called a margin. Thus, SVM tries to make a decision boundary in such a way that the separation between the classes is as wide as possible. And support vector machine is a discriminative model, draws a hyperplane in n-dimensional spaces, not only two-dimensional, but it's n-dimensional spaces within the highest margin. The main purpose is to separate between the what to say to make a decision boundary in such a way that the separation between the classes is as wide as possible. Now let's move on to results.
Abhishek, I'll take this.
Yeah, fine.
Okay, now Abhishek, Prajwal and Digvijay have discussed a lot about the various feature extraction algorithms and the classification algorithms. Now, for our project, we can only choose one, that is one feature extraction algorithm and one classification algorithm. So, what we are going to do, I mean, it's common sense that we are going to take the best of all the combination. So there are totally 12 combinations possible. So if we actually did an experiment, that is, we trained and tested the model on our data, and we took the model which offered the highest level of accuracy, precision, and recalls. These were the performance metrics which we took to evaluate the model. So the best combination was by far ResNet 50 and support vector machine. So ResNet 50 and support vector machine has offered us around, as you can see in the first, in ResNet in SVM, 97.80, 97.46, and 97.66. So what is accuracy? You know what accuracy is? Like, out of all the instances, how many instances did our model predict correctly? Okay. Coming to precision and recall, it's all about the amount of, there is a formula which we won't cover. We've actually covered it in our previous presentation, but to keep it simple, precision and recall basically deals with the number of true positive and false negatives. So the higher the precision and recall values are, the lower will be the false positive and false negative values of our model. So these are our results. So this ResNet 50 and SVM will be used in our final model, that is in our when we deploy the model basically. So next slide.
One second.
Before we go to this, I think we'll show the code so that you can get an idea of what we are saying. So Abhishek, you stop sharing your screen. I'll share mine. Now, actually in this milestone, we are actually saying how we implemented the whole bunch of theory we have been monotonously reading from the past few milestone. So let me give you a journey of where we started and where we are now. Actually, we are completed with the projects, our project. We might undertake some minor UI changes to make it more accessible, So let me just walk you through where we started and where we are now. So in January, we thought of deep learning project, but we didn't know anything about deep learning. So the best place to start was cats and dogs. So this is the basic problem everybody would start while they take a project for or to understand deep learning and classification. It's just like the iris data set that data scientists use as their first project. It's called as the hello world program of data science. Similarly, this is the hello world program of deep learning and computer vision, that is cat versus dogs. So we took a cat versus dog program and we studied the model, okay, how they did it. So as you can see, the model was a very simple one, and the accuracy obviously was a bit low too. The accuracy was high, but it was fluctuating. So this means that whatever the results we are getting was overfitted. Okay, overfitting means it's like how can I say? You are preparing for these questions, like you can say if a lecturer gives around 4 questions to your internals for the upcoming internals and say, or read only these questions. So if he asks any questions out of these 4 questions, then obviously nobody would answer, because people have only prepared for only those 4 questions, right? This is overfitting. Okay, so this was our problem. It could only perfectly classify objects which it knew how to classify, and the rest of it just gives some bullshit result. So as you can see, it took a lot of time to train it, and the accuracy here, you can see the graph. I hope it's visible. Is it visible, Abhishek?
It's visible. It's visible.
Yes,
Yeah.
yes.
You can see here the validation losses is keep on increasing, and even the accuracy too, it's fluctuating a lot. right? And the accuracy is shit too. It's like 0.650. That's, I mean, imagine if we have 0.650 in fire detection scenario, it's like a slightly better probability than a coin toss. So this is unacceptable. So from here we moved on to, we experimented with different layers and different hyper parameters and parameters, and we got here. Basically we carried out minimum changes to the program, and we again did the training. So here the accuracy was better. Like here you can see the confusion matrix that's visible. You can see it's around 80 to 70%, 80 to 90% actually. But still, yeah, here you can see the accuracy is 91% for non-fire, and for fire it was 83.5. Still it is unacceptable, because out of like 1 out of every 10 occurrence it will classify it wrong for non-fire, and for fire every 2 instances of fire will be treated as non-fire. So this what this would mean is there's potential for, lives, I mean, potential to cause more accident than what's actually been caused due to existing system, because the existing system are plagued by false alarms, and we are trying to replace it with a better system and more accurate system, and 83% is simply not enough. So from there we took the transfer learning approach. So in transfer learning approach, as Abhishek previously told, we take a pre-built model, right? So the pre-built model is trained on lakhs of images, so obviously it would provide a better performance, and we are only using it for feature extraction. That is why it's called as representation learning. So in transfer learning itself, we can do transfer learning in 4 methods. We are only using one method, that is representation learning. Okay, so the final this would be the code of our training part. So we are importing packages, models, blah blah blah, and I don't think it you can understand much from this, because even I couldn't understand much at the beginning. So either way, we extract the features and we save the features and the labels. That is the features, meaning the features of the image from the feature extraction, and the label fire or non-fire. Then we pass it to a classifier. So this is a separate Jupyter notebook. We carried out the whole training thing in the Jupyter notebook, and the testing thing in testing and deployment in Spider, because Jupyter files are .ipynb and Spider is .py. So .py files are basically, you don't need a Jupyter notebook or Anaconda environment to to just run the program. It can be run in any Python system. So as you can see, this is the training part. This is where we got the 97, 98, 95%. So we are using a stratified k-fold method. In stratified k-fold method, we are going to divide the data set into multiple parts, like 8 parts in our case, and train the system on 7 parts and test it on that one part. And we repeat the same process until all the 8 parts, each of the 8 parts, get a chance to become the training set. So obviously we'll get 8 results, right? So we just sum up everything and we get the average accuracy, precision, and recall. So here for naive base it was 93, 91, and 0.92. Okay, so in decision tree 2 the accuracy was, let me just check, 94, 93, 94. So the best results we got was for SVM and logistic regression. The best is SVM by just a small fraction, like 0.00 something. So the average accuracy, precision, and recall values were 97, 97, and 97. I'm ignoring the rest of the digits. Either way, it's 97%. So we took this and we built our model. Okay, that is, we deployed it. So this would be all the functions. We took a modular approach. That is, we divided the functionality into the entire functionality of the code into functions, and we imported it as a module. Okay, so this is modular programming. So what is the advantage of this modular programming is, so for example, there is some issue with Firebase or with the GUI or with the, you can say, the classification itself. So we have code here. As you can see, this is send mail to send the mail in case of fire, and this is the Firebase part configuration. This is the login part, and next this is the add entry part. I don't know if it's visible because the code is a bit small. Let me zoom into this. I hope it's visible now. So next we have add entry to adding entry. So we have a lot of more functions. Okay, load feed model, load CLF model. So just like we include libraries in C, ash include stdio.h, standard input output, or console input output.h. Similarly in Python we use this. That is where is that? Imports is import JSON. Yeah, from all functions import star. So what this means is all functions is the Python module in which we have stored all our function, and from that we are importing star. It's simple, right? Compared to C and C++, we don't need any hash include, and and actually in C you have to provide a particular format to make it as a library. In here you just need to save the file in Python with function. That's it. You can easily use it. You don't need to do any specific surgery to that file to make it as an header file. Okay, so let me execute this. Okay, we have there's already an instance running. So this is the GUI of our code. Okay, so I'm currently logged in with my Gmail, and I'm assigning an alert mail. The alert mail is basically to which email will the alerts be sent. The about to the Firebase login and sign up is where the log is maintained. Okay, so when we proceed, we go into this small window right here. So here we are presented with two choices. We either can run in video mode or image mode. Okay, so let me run it first in image mode. Okay, we can select the directory. In image mode, you are gonna select the directory which consists of test images. You can select it and you can run it. Okay, so if you can see a window just popped up. So if you press Q, it will move on to the next image. Okay, so these are all non-fire images, so it's classifying perfectly. So when it comes to video, I've already shown you how it actually looks, but I'll show it again just in case if you have forgotten. So this is a image mode. Okay, so there are a lot of images. Let me just run through it all. As you can see, it can also detect small fires like that one. It only uses what, like 10%, not even 10%, like 5% of the space. So yeah, the model can predict fires. Yeah, we have forest fires here, and we observed a similar performance in this one too. That is videos too. Like the same videos were used as images. Either way, let me go to here. Yeah, F11. Okay, now we are gonna run in video mode. Okay, so this is a, you can observe the result is flickering. That's because we didn't take the average result. Okay, that's it was a short video, so we didn't take the average of all the frames for now because we wanted to show you how it flickers, because the model is trying to predict what's happening. So next would be, let me take something which I haven't showed yet. Maybe this one. Yeah, this would. So this is a like a campfire. So the fire is pretty big, so you don't see any flickering. So if the fire is small, we observe flickering. So this is the GUI. The GUI was built using tkinter. So tkinter is a simple GUI tool uh, with which we can build desktop applications. Like, we did not want to build a web-based application because you cannot just pass in videos on the web because it requires a significant bandwidth. I mean, it can be done, but for our project we haven't done it. We are taking a local machine approach. So that's why we thought of using tkinter for developing our whole GUI. And tkinter can only be used to, as I've said, it can only be used to make simple GUIs, not complex GUIs. So you might wonder how I was able to do this in the left fire detection using deep learning v35. Obviously it's an image. Okay, The image was created using a website called Creately. It's one of the best website that I've come across, with which you can create flow charts and anything you want with industry grade quality. Okay, Abhishek, I think we can move on to, let me
Chetan,
close this. Yes, sir.
yeah, if you're done with the logic part, I think the evaluators have some question. They might just go through that, isn't it?
Yeah, sure, sir. I mean,
GUI and all we'll discuss later
okay,
if it is required. Yeah.
okay.
So
We
coming on
still have
yes, sir. Yeah,
to
yeah.
discuss about the test cases.
Okay.
Maybe I'll conduct another session for like
Another
10
session
10
should be there, I guess. Yeah.
for solving, I mean, for Q&A. Okay. So
Yeah.
Abhishek,
Till now, if the members have something to ask,
yeah, if you have any questions, you can
yeah.
go ahead.
You have explained one decision tree, right?
Yeah.
Whether a person decides to go out or not.
Yeah.
Can you just explain the same for your project?
Yeah, this is a good question actually. So now, Abhishek, can you just show us that slide decision tree?
One second.
So
Just
let me. Yeah, sure.
stop sharing.
Oh yeah, sorry. Just a minute. Now, decision tree in what Rajwal explained. It's a classic example where decision trees are used to classify yes or no type image queries, right?
Right. Yeah.
So in the image decision tree, Abhishek.
Yeah.
So in the image, you can see that there is outlook, humidity, and wind. These are what are called features, right? So what are the features in our case? The features in our case are coming from.
Apart from you, does anybody know about this?
I think Abhishek knows. Abhishek and Digvijay knows, I guess. That is a black box.
If they're sure, let them explain.
Abhishek, are you sure, or should I continue?
Like, what was the exact question, ma'am? I didn't get that.
I mean, what are the features and labels in our case for that decision tree?
About that, okay. Few features like whether it's fire or non.
I will join in 1 or 2 minutes.
Okay, sure, sir.
Okay, sir. Yeah.
Okay, then we'll think we'll wait for a minute. Let's continue. Either way, this is not that important, so I think we can continue. There isn't much content to be discussed here. So either way, just a minute. Okay, testing. So testing is basically we are putting our
Kalam is online. You can answer.
Yeah. Abhishek, please answer that question.
Yeah, ma'am. For your question, we are not actually having any labels for this because we are using ResNet 50, which extracts the features in terms of numbers. As I told earlier in my first slides during ResNet 50, we are extracting the features in terms of number. So we are getting which is actually a black box testing. That's why we call it as black box testing. The reason is like extracting the features as numbers will be more computably easy for the computers rather than the labels or the names given to it. So we have just used that kind of approach.
To add to what Abhishek just said, now ResNet 50 is a black box, right? All deep learning models are black boxes. You might have come across this concept because the computer itself is adjusting the weights and other parameters by itself without letting the user know, or the user cannot understand. That's why there is so much hype about one day artificial intelligence will take over and make us all as slaves. The main reason is because of this nature, black box nature. So when we are feeding an image into a black box, that is ResNet 50 or any deep learning model, the output we are getting is also a black box. Okay, and you have to look at the output size, that is 2048 features. So if we were to draw a decision tree for 2048 features, it would be huge, like too huge, right? This is like 5 features. So in that 2048 numbers, all these numbers are taken as features. So a tree will have 2048 features to decide. So these are the two reasons why we cannot, visualize the whole decision tree in terms of, I mean, in case of our project or any other deep learning project, for instance. So if you have any other doubts, you can ask. I think ma'am is muted. Abhishek.
One second. I'll see.
Yeah, no problem. I can unmute myself. Okay, that was the question. Did you finish answering it? May I
Yeah, yes,
request?
ma'am.
Yes, ma'am.
Okay, fine. That's it then from my end.
Okay. Another thing is, we have to realize the limitations of the human brain. Like if you take SVM, support vector machine, Abhishek said that we are drawing a hyperplane, right? He showed us a two-dimensional, like we had circles and we had squares.
Yeah.
That is 2 features, that is n features. So if we have 2048 features, we are drawing a hyperplane in 2048 dimensions. The human brain can only comprehend 3 dimensions. I mean, there is a fourth dimension which we call it as parallel universe, which is popularized by comics, movies, and even in Ramayana we talk about the fourth dimension or the spiritual or whatever. So imagine 2048 dimension drawing a line or a plane in 2048 dimension. That is simply incomprehensible for a human brain. So yeah, coming back to testing, that is unit testing. So in unit testing, basically there are a lot of testing methodologies that is been specified by Heyman sir, but most of these methodologies can only be used in the IT industry, like A/B testing and some other testing like receiver testing or something. So these are carried out in software engineering environment where we have different development and testing teams. So for our college level, we can only select around 3 or 5. We have selected 3. So first is the unit testing. We divide the entire project into units. First one is the login GUI. You can see the various test cases. So there are 4 test cases. So you can see the description here. One is we try to log in using valid Firebase credentials. We passed it obviously, and the main ability a program should have is to handle invalid input. Like a user can input anything, right, to just test our software. He might enter numbers in email and he might leave everything blank and press login. So we must have able to handle erroneous inputs. So first erroneous input would be invalid Firebase login credential, that is the password. So when he enters a wrong password, we get an output as invalid password. So where are we getting this from? We are getting this from the Firebase server. Okay, it returns us a HTTP error message, which has a JSON object. We basically parse the JSON object. I can show you the code. We basically parse the JSON object using the JSON library and fetch the error message and print it. That's it. So even the same thing for email too. If he inputs a erroneous email address which is not signed up, then we put the same thing. Okay, next would be handling empty input. Obviously email not found would be the message to throw, because you can't say password not found. Okay, next slide. Sign up. Oh, is there a fifth test? The fifth test case is the enter email input, no input email, and yeah, this is the final test case. So yeah, there is one other I missed, that is a weak password. So while signing up, this is the signing up thing. So the email exists, email password, these are all same with the login too. The unique cases would be sign up for, that is when we are signing up for Firebase, we should enter a password that must be just 6 characters long. I mean, they have a weak password policy for Firebase because Firebase is mainly used with the IoT devices to pass the inputs and outputs. So it should be at least 6 characters. So when the entered password is less than 6 password, we give an error message that is password should be greater than 5 characters. And sign up one, that is, yeah, these are all invalid. What happens when we give invalid credential like email and password, or when we try to sign up using the same email, if we do that, we'll get a sign up error like email exists. So next. Okay, Abhishek,
Digvijay.
was this assigned to Prajwal or Digvijay?
I will do it.
Yeah, okay.
Okay, coming to the detection GUI, we have tested 4 test cases actually. First test case is running the model with valid video path. We will select the video mode as we have seen in our GUI, and then open the video file. Input given will be video path. Expected output is the detector starts the process of detecting the fire, whether it's fire or non-fire. The actual output is the same. Then the test case is passed. Second is we will opt to choose a valid image path rather than a video path. So we will select image mode and open the image directory. The input given will be that it is image directory path. The detector expected output is the detector starts. The actual output will be also the same. Then the test case is passed. In third test case, what we do is we don't give any path, so there will be no path selected. So the input given will be no path. What the GUI does it will pop a message called it shows like please select the path. So the actual output will be the same. Then test case is passed. Last is that we quit the detection window. So we press the quit window. Expected output is the window will be closed. This test case is also passed.
Okay, next. Abhishek. Yeah, compatibility testing. So this is the second testing method we have chosen to evaluate our application. So in compatibility testing, the definition states that we run the application on different environment. If it's a web application, we try to run on different web servers, different hardware, and different networks. So in our case, ours is a desktop application, right? So our application must be able to run in different operating systems. So there are only two major operating systems that is used everywhere, that is Windows and Linux. So in Windows, it successfully ran in Windows, like I just showed you, right? And in Linux Cinnamon 19.2, there were some suitable library changes that had to be made. Like computer vision is not mentioned in the pip, that is a Python package manager for Linux. So that was a great bit of issue, because we had to search a lot of go through a lot of Stack Overflow pages to just get the right computer vision software CB2. So other than that, there were not maybe CUDA too. Yeah, CUDA is basically suppose you have a graphic card in your laptop. Okay, so machine learning models are now run on graphic card instead of CPU, because graphic card has more cores than CPU, but CPU has powerful cores. We do not care about power here, we care about the number of cores. So GPU has a lot of cores, but traditionally GPU is mainly used for like gaming, that is rendering graphics and videos. So how do we use it for machine learning? So NVIDIA and even AMD has given us a toolkit. NVIDIA's toolkit is called CUDA. Okay, CUDA enables us to run machine learning and deep learning.
Chetan,
Yes, sir.
can you hurry it up? We have a meeting there. It's almost
Okay,
like
okay,
one
sir.
and a half hour. It's getting quite a bit long.
Okay, sir. Okay, sir.
Yeah.
So our application worked in both Windows 10 and Linux Cinnamon 19.2. So Abhishek, next. Okay, functional black box is next. In functional black box testing, we basically test the input and output. So
As we
here
have
you
already
can
shown
see
the
that,
videos and images.
yeah, we have used 12 videos, and we have all the model has able to predict fires in all 12 of these videos. But the only issue we faced was in non-fire, because in non-fire it misclassified one video, that is headlight during the night time, because
Yes.
it has similar features to fire. Okay, so it was tested on total of 12 fire videos and 12 non-fire videos, and it misclassified one non-fire video and correctly classified all fire videos, and it was over various environments like fire, kitchen, outdoors, indoors, every environment. If when we get a chance, we'll show the videos maybe in milestone 4. So next, I
That's it.
think that's the end of it.
That's
Okay,
fine.
if you have any questions, you can
Impossible.
ask us, or if time is a constraint, you can message us in group.
Yeah, probably that should be better. If they have something, they will put it in the group. If
Okay,
nothing,
sir.
we'll write it up.
Okay, sir.
Fine, sir.
Thank you.
Thank you, sir.